Hello, all algebra students. So we are working on the last section that we'll be covering at least in chapter 3. And this is talking about compound inequalities. So remember, chapter 3 is all about inequalities. And now we're talking about compound inequalities. Now remember, compound means exactly what you would think. Think like a compound fracture or a compound bow or a compound leaf. Compound means more than one. So here we're going to be having more than one inequality in the same problem. So what I'd like for you to be able to do by the end of these notes is to distinguish between and or inequalities and to be able to solve them. So here it says a compound inequality consists of two distinct inequalities joined by the word and or the word or. So I'm going to go ahead and highlight that. And what's important, as well as the word that we're talking about, compound inequality, there are two types of compound inequalities. There are and problems and there are or problems. And you're going to see that in action here in just a minute. But first, I'd like to just talk a little bit about the graphs of each. So first of all, the graph of an and problem. The graph of an and problem overlaps. So that's important. And overlaps. So you can see down here in this final answer, so we had one inequality and the second inequality, and here they are combined. We have them overlapping in that section. But when you have or graphs, or is the graph of each individual graph, and they go in opposite directions, okay? So here we had our two inequalities combined with an or, and on the same graph, they're going in opposite directions. So and go together, or go apart. Okay, let's go ahead and look at a couple of these examples. Problem 1 says all real numbers that are greater than -2 and less than 6. All we want to do is graph these. So remember, all real numbers means x. So I'm going to say x is greater than -2 and x is less than 6. So these are my two inequalities that I need to graph. Because I have an and, I know that they should go together. And I'm going to go ahead and number my number line and see what I get on here. So I'm going to start back here at -3. Because I wanted to make sure that I got all my numbers on there. I needed -2 and 6 on my number line. So let's graph the first one. I want x greater than -2, so I'm going to go to -2. Put a circle on it. Because there's no line, I'm not going to fill it in. I'm leaving it an open circle. Then, because my variable is on the left right here, I am able to follow the direction of my inequality, and I'm going to shade to the right. So we're just shading to the right a bit. Okay. I also have the inequality x is less than 6. So I'm going to go to the 6, put a circle on it. I'm leaving the circle open or not colored in because there's no or equal to part to this symbol. And because the x is on the left, I'm able to use my shortcut, and this says shade to the left. So now I'm shading to the left of this dot. And here is where my overlap is. Let's look at an or example real fast. In this next problem, it says all real numbers that are less than 0 or greater than or equal to 5. So let's just write each one down. I want x to be less than 0, or I want x to be greater than or equal to 5. So here's my two inequalities. I'm going to go ahead and now number my number line. Let's start with the x is less than 0. I'm going to go to the 0, put a circle on it. It's not getting colored in because there's no line, and I'm going to shade to the left. Looking here, I have x is greater than or equal to 5, so I'm going to go to the 5. I am going to color this dot in because I have the line underneath, so I'm going to color it in. And I can use my shortcut the way this is written because the variable is on the left. I can look at the way that the inequality is pointing. If this kind of looks like the top of an arrow, that is pointing to the right. So I'm going to shade this to the right now. So here we have the lines going in opposite directions. They're going away from each other. On the bottom part of this front page of notes, we have a little extra thing for you, and it is, what is the difference between x is between -5 and 7 versus x is between -5 and 7 inclusive? Inclusive. Okay, so first let's talk about what x is between -5 and 7, what that means. I am going to number my number line, and I know that I don't have enough notches, so I'm going to label them by 2s. So I have 1, 3, 5, 7, 9, 11. And then we're going to have negative, that's going to be 0, then -1. -3, -5, -7, -9. There we go. I'm going to go to the -5, put a circle on it, and I'm going to go to the 7 and put a circle on it. I want x to be between these numbers, so I'm just going to shade everything in between them. Now, what's the difference between x is between -5 and 7? Inclusive. Well, notice how the word inclusive sounds like the word include, and that's because they basically mean the same thing. This is going to include the numbers mentioned. So we talk about being inclusive in school, meaning we accept everybody and we encourage everyone to participate and work with us. So here with the inclusive part, we want to kind of let -5 and 7 participate in on the action as well. So let's do our number line again. I'm going to go to -5. And because I'm including these numbers, now I'm going to color it in. And I'm going to go to +7 and color it in as well. And then I shade in between. So the only real difference is the fact that the dots are colored in compared to the one above, which means that -5 and -7 are part of the answer as well. All right, let's move on to the next page of these notes. Let's start talking about how to solve these types of inequalities. Here it says solving a compound inequality involving and. So we're solving an and problem right now. And it says, what are the solutions of -3 is less than or equal to m minus 4 less than -1? Graph the solutions. Okay. There are 2 ways that you can do this. I'm going to show you both ways. The first way is to split it up into 2 inequalities. So I'm going to look at this part first. I have -3 is less than or equal to m minus 4. Then I'm going to look at this half, and that's going to get me m minus 4 is less than -1. Now I have two inequalities that can be combined to get me 1, but I just rewrote them so I can solve them individually side by side. So let's do that right now. I'm going to add 4 to the right and add 4 to the left. So down here, I'm going to have positive 1 is less than or equal to m. Over here on the right side, or on the right equation, I should say, I'm going to add 4 to the left and add 4 to the right. They cancel, and I have m is less than 3. So here are my two inequalities. Remember, it's a compound inequality, so you should always have more than one in compound inequalities. So then I would take these and graph them. If you don't want to rewrite your work, you can leave and problems as one single inequality or one single written problem. So let's rewrite it. I have negative 3 is less than or equal to m minus 4, which is less than negative 1. Just like in equations, when we add one thing to one side, we have to add the same thing to the other. Well, here, because I have two sections of inequalities, I can draw my line down them. So now, whatever I do to the middle, I must also do to the right and to the left. Whatever I do to the left, I must also do to the middle and the right. So I'm doing the same thing to all three sections, just like I would if it were only two. Write that a little better. Okay. So we will get the same answer, but I'll still show you how to do this. So I want to isolate the m. I am going to add 4 to the middle, to the right, and to the left. Okay, they cancel in the middle, and I'm left with m, and then I keep my signs the way they were. Then I say, what's negative 1 plus 4? Well, that's positive 3. And what's negative 3 plus 4? That's positive 1. And here is my compound inequality once again. It's honestly the same amount of work. It's just whichever makes better sense for you. So I am going to use these numbers, and I'm going to put them on my number line now. 0, 1, 2, 3, 4, 5, 6. Okay, that's enough. So I'm going to go to the 1. I'm going to put a circle on it. And then I'm going to go to the 3 and put a circle on it. Now the 1, or this one right here, notice how it needs to be colored in because I have that or equal to symbol right there. And then because I can recognize that it's all written as one expression and I was told that this is an and problem up here, I know that I just need to shade in between those numbers. So that's what I'm going to do. Moving on, let's look at another one because that was your first time solving an and inequality. So let's look at another because I know that they can get a little tough to follow. So this one says, what are the solutions of negative 2 is less than 3y minus 4, which is less than 14, and then graph the solutions. I'll solve it using both strategies so you can see it. I'm going to rewrite this as two inequalities. I have negative 2 is less than 3y minus 4, which is less than, I'm not going to write that, sorry. So I have my first part, and then I have 3y minus 4 is less than 14. So here are my two inequalities, and I'm going to solve them like I would any other inequality. So I'm going to add 4 to both sides of this one. That gets me 2 is less than 3y. Then I'm going to divide by 3 on the left and right sides, and I get 2/3 is less than y. Let's work this one now. I'm going to add 4 to both sides. Then I have 3y is less than 18. Divide by 3 on the left and right, and I have y is less than 6. So here are my two inequalities. Let's do it where we leave it all as one inequality so you can see that again. I have negative 2 is less than 3y minus 4, which is less than 14. And let me just say this. When you're doing your homework or you're filling out a test or a worksheet, whatever, You don't have to do it both ways. Choose whichever strategy you like more and do it that way. You don't have to. I'm just working it twice so you can see it works using both strategies, but you don't have to do that. You just choose one that you want to do. Okay, so anyways, here are my 3 sections of my inequality, and I'm trying to isolate the y in the middle. So I'm going to add 4 to the middle, add 4 to the right, and add 4 to the left. So that gives me 2 is less than 3y is less than 18. Now I'm going to divide by 3 in the middle, divide by 3 on the right, and divide by 3 on the left. So that cancels with the 3's in the middle, and I have y isolated, and now I have 2/3 is less than y is less than 6. This answer right here, written as 1 inequality, and this answer right here, written as 2 inequalities, is exactly the same. It's just written slightly different. So there's no actual difference in the answer itself. So now what we're going to do is number our number line and graph this. So I know that my boundaries are 2/3 and 6. I know that I don't have a 2/3 marked on this, so we're just going to have to eyeball it, and I'm going to say that that right there is 2/3. I'll label it so you can see. I would obviously have something labeled for you a little better on a test or something like that. So I'm going to say that this is my 2/3. I'm going to put a circle on it, and I am not coloring it in because there's no line underneath. And then I'm going to go to the 6 and put a circle on it. Not coloring it in because there's no line underneath. And then because I know that this is an and problem, and you'll know it's an and problem because it's written as one, like one single line, I'm just going to color in between those points. And there we have it. That is our solution. We have one more page left of notes for this section, and then we'll be done. So, oh boy, a word problem. Problem 3 says, to earn a B in your algebra course, you must earn an unrounded test average between 84 and 86 inclusive. You scored 86, 85, and 80 on the first 3 tests of the grading period. What possible scores can you earn on the 4th and final test to earn a B in the course? Okay. So let's just organize what we know. We want our grade to be between 84% and 86%. So we know we want it to be between those things. But it is okay for us to earn exactly 84 or exactly 86. The reason I know this is because it says inclusive right here. So remember, inclusive means to include. So I'm going to include 84 and include 86, which means I need to put my or equal to symbol underneath both of those inequalities. Now let's figure out how on earth am I going to write an equation for the grade. So it says I want an unrounded test average between 84 and 86. So I want that grade to be my average. So I'm going to go ahead and label that average grade. Now you might not remember, or maybe you do, I don't know. How do you calculate an average? To calculate an average, add up the numbers and divide by how many there are. So here we have 3 tests, and we're going to have one more test that we haven't taken yet. So we have 4 tests that we're going to add up together. So it's 86 plus 85 plus 80 But I haven't taken the last test. I don't know what I'm going to earn. So since it's an unknown, I'm going to label it as X. And then I'm going to divide that by how many numbers I have. So 1, 2, 3, 4. I have 4 points of input, so I'm going to divide that by 4. Okay, now what we're going to do, I'm going to go ahead and add these 3 numbers together to just make this a little bit simpler. So I'm just simplifying it a little bit, and this is going to get me 251 plus X over 4. This is my equation, or expression I should say, that I'm going to put in for my average grade. I need this expression to end up equaling between 84 and 86. So now I'm going to finish this inequality, and I have 84 is less than or equal to 251 plus X divided by 4, which is less than or equal to 86. So let me say how I did that one more time. I'm finding the average grade, and to find the average, I add up all my test scores and divide them by how many I had. But because one of my test scores is unknown, I have to leave it as X, but it does still count as one of the tests, so that's why I'm dividing by 4. So now, let's divide this into 3 parts and start solving. I want to get rid of this division by 4 first. And to get rid of something that's divided by 4, I'm going to multiply by 4. So I multiply by 4 in the middle, I multiply by 4 on the right, and I multiply by 4 on the left. When I rewrite that, I get 336 is less than or equal to 251 plus X, which is less than or equal to 344. So all I did was take that 4 and multiply it to these numbers, and then use my calculator to get my new numbers. Now I want to move this 251. Well, to get rid of a positive 251, I'm going to subtract. So minus 251 to the middle, minus 251 to the right, and minus 251 to the left. When I do that, I'm left with X is less than or equal to, and my new values are 93 on the right and 85 on the left. So what this means is, if you score between an 85 and a 93 on your 4th test, like 85% to a 93% on your last test, then you will get a B for your algebra score. And that's all for that example. We have 2 more problems where we're solving OR problems now. So we've only done 3 AND problems. Let's look at an OR problem real fast. So these are OR, and remember, OR means graph in opposite directions. Okay. So all you're going to do here is to look at your first inequality and your second inequality and solve them both. So looking at this one, I'm going to subtract 2 from both sides, and that gets me 3t is less than negative 9. I'm going to divide by positive 3 on the left and right side, and I get t is less than 3. So that's my first one. Now let's look at this one. I have negative 4t plus 5 is less than 1. I want to move the positive 5. To move it to the opposite side, I do opposite operations. So I'm going to subtract 5 from the left and subtract 5 from the right. And I'm going to get negative 4t is less than negative 4. Now I'm ready to divide by negative 4. You do not add 4 here because these are right next to each other. So that means multiplication. So I'm going to divide by negative 4 on the left and divide by negative 4 on the right. And I'm going to have t. I'm flipping the sign because I divided by a negative, and then I get positive 1. Now that I have my 2 inequalities, I'm able to graph them on the number line. So I'm going to label this number line. And I'm going to go to t is less than 3 first. So I'm going to graph the 3. Oh, I accidentally made a mistake, you guys. I missed a negative sign right there. There we go. I was looking at that and I thought, okay, hold on, what's going on? Let's see here, -1, -2, -3. There we go. Sorry about that. This should be -3 because -9 divided by 3 is -3. So I'm going to go to the -3, put a circle on it. I'm not coloring it in because there's no line underneath. And then this is going to be shaded to the left. Now for this one, I'm going to 1. I'm going to put a circle on it. Not coloring it in because there's no line underneath. And this one's getting shaded to the right. There we go. Let's do one more. This is our last one. I know these notes are starting to get a little bit long, but this is the last one, and then we're done with all of chapter 3. So it says, this accidentally spaced it a little bit weird. It says, what are the solutions to -2y plus 7 is less than 1? So I'll go ahead and write that down here. -2y plus 7 is less than 1. Or 4y plus 3 is less than or equal to -5. Looking at this first problem, I'm going to go to the side with the variable. So I'm going to subtract 7 first, and I have -2y is less than -6. Now I want to divide by -2 on both sides, and I'm going to get y is greater than +3. Keep in mind I switched the sign because I divided by a negative number. Let's solve the second one now. I'm going to subtract 3 from the left and from the right. And I have 4y is less than or equal to -8. Now I want to get rid of this 4. And to do that, I'm going to divide by 4 on the left and right sides. And I have y is less than or equal to -2. I didn't change the sign this time because I divided by a positive number. So now we just need to graph our solution, and then we are done. So let's do this one first. Y is greater than 3. Let's go to 3, put a circle on it. I'm not coloring it in because there's no line underneath, so I'm just shading to the right on this one. Then I have y is less than or equal to -2. I'm going to go to the -2. I am coloring it in this time because there's a line underneath it. And because I can use my shortcut, remember the variable is on the left, I'm following the direction of my inequality. I'm shading to the left. And there you have it. I know these notes were long. I apologize for them taking more time than usual, but it was a big unit, and we will be practicing on these for 2 days to make sure that you really understand it. So if you have questions, bring them to me tomorrow, and have a good night.